So here's a pair of earrings I made recently. They were a present for my girlfriend who likes baking and is obsessed with miniaturized versions of normally larger things. So I made her a tiny whisk and a tiny chef's knife. And if you have a few minutes, I will show you how I made them. Let's start with the knife. It's all wavy and weird looking because it's made of pattern welded steel. I used to actually make this stuff myself, but I don't have access to a forge anymore, so these days I buy cutoffs and blanks from local knife makers. The billet I'll be using today was made by Jeff Flatto, by the way. I started by drawing the knife in my favorite CAD program and then printing it out. This was then glued to a piece of brass that I cut out and filed to make a template, which I used to trace the shape onto a piece of metal with a scribe. That blue stuff all over the metal is called layout fluid, by the way, and it's there to make my lines more visible. Think of it kind of like a paint, almost. Now, because I'm a hack fraud who's garbage at forming, I cut the shape out with a saw frame and then filed it to the correct profile. I also used a hand file to give it the appearance of a wedge shape, though of course it's not sharp in the slightest because, well, of course not. Afterwards, there was a lot of sanding to get rid of my file marks, and thankfully I only have to go up to 220 grit for now. I'll explain more on that later, but I also made sure to refine all the curves and such with a silicone wheel mounted on a tiny chuck that was in my flex shaft. Yeah, this part took a while. But after all that's done, it's time to harden and temper it. Technically, I don't need to do this, but I think it's funny and you can't stop me, so it's happening. This involves heating it up to around 1500 degrees Fahrenheit and then dunking it in vegetable oil, which makes the steel very hard, but also very brittle. So I'm going to go ahead and temper it by putting it in the toaster oven for 1 hour at 400 degrees Fahrenheit. You can tell the temper of steel by the color of the oxide, and that yellow hue is exactly what I want to see. Unfortunately, though it's pretty, that oxide layer needs to go, because the next step is sanding it all the way up to 1500 grit. Now, as a side note, I was always taught to only take the thing up to 220 before hardening, because you often have to back polish to that grit anyway when you're done with the tempering process. Probably not necessary in this case, but whatever, it's a force of habit, so that's what I did. Anyway, so far it's looked like normal steel, but once I etch it with the ferric chloride, the pattern will start to be revealed. I go over why this happens in a different video, but to give everyone a brief summary, this works because the pattern welded steel is made of two different steel alloys, and one of the alloys has something in it to resist the acid. In this case, I believe it's nickel. Now, this makes it so that the acid only eats away at one of the layers, and as a result, you see all the deformations that you did prior to this step very clearly. If you want to learn more about this, there's a video somewhere in my profile that goes into more detail. It's the one where I'm acting like an idiot and wearing a wizard's hat. I also mispronounced a word in that video, which is a cardinal sin on the internet. Anyway, moving on. After some light brushing with some fine grit sandpaper, ideally under running water, I'm pretty much done with the knife itself. Now all I need to do is get some jump rings on there and then very carefully solder them shut. I've got some heat-resistant clay on here to make sure I don't ruin the temper, because I gotta get that jump ring about 1000 degrees higher than the temper of that knife to make the solder flow. Next up is attaching the earring hardware. Now, I personally always make my own earring hooks, so I did just that, and then attached everything together with more solder, and after all that was through, there was just a little bit of cleanup with the silicone wheel, and I was done. Now let's move on to the whisk. So I started by getting a whisk from my kitchen and studying it very carefully. Turns out it's really not that complicated, it's literally just a bunch of wires stuffed into a tube. But this does present a design challenge, because you have to figure out what gauge those wires need to be, and what the inside diameter of that tube needs to be so that you could shove all those wires all up in there. So there's 4 wires that make up the whisk, but there are 2 ends to each wire that you shove in there, which makes 8. The math should check out, but if it doesn't, please be patient, I do have 2 art degrees after all. But anyway, I decided to work backwards and figure out how thick the wires had to be. They couldn't be too thin, otherwise they would be rather fragile, and they couldn't be too thick because then they might not bend quite as readily or fit in the tube. Eventually I settled on 20 gauge wires, which for those of you who don't use freedom units, that's about 0.8 millimeters. I also determined that I would need a tube with an inside diameter of about 3 millimeters to accommodate all those wires. Unfortunately, the only tubing I had anywhere near that size was the heavy wall tubing that you would usually use for gem setting. This stuff has thick outside walls and a very small inside diameter, and it would not be suitable unless I were to do something crazy like, I don't know, drill into it with my drill press, but that just felt like cutting the Gordian knot, and I figured there had to be a more elegant solution. And after thinking about it for a bit, I just drilled it out. Yeah, it turns out all other things being equal, the simplest solution is often the best one. Now that I had the proper sized tubing, the next step would be to bend all those wires into a more whisk-like shape. Before committing to the silver, I practiced with copper wires, and once I found a pair of pliers that would get me the correct bend every single time, I went ahead and made 4 little, they're not splines, they're not tines. What do you call those things in a whisk? I don't know, I made the whisk appendages with my pliers and then stuffed them into the tube. It was kind of difficult because they wanted to kind of spring out, so I had to adjust them very slightly every now and again by bending a flat spot on them and then just very slightly tweaking them back and forth with my pliers. But eventually they all got in there, and I soldered them all together off camera because, again, I'm a hack fraud and I'm also bad at social media. Anyway, I capped off the tube and put a jump ring on top of it, and then made another earring hook and attached another jump ring to that. And then another round of careful soldering to get that jump ring closed, and these were done. Well, I had to do a little bit of cleanup with that same silicone wheel, but either way, it doesn't really matter. Cool. Yeah, and that's really about it. It's a fun project. Before this whole thing started, I told her that it would be way too complicated to do something like this, which I lied. And, yeah. You may think this is a Christmas present, but the truth is this was made several months ago as a birthday present. See, there's even a tiny car that goes with it. But, nonetheless, that shouldn't stop you from having a good holiday, which I hope you do. So for the 12 of you that have wondered where I've been for the past couple months, you might be pleased to know that I've been working on longer form YouTube content. Now, I can't really say much about this right now, but I will say that these will be longer form educational videos on metalsmithing that allow me to go much more in depth. That being said, I've also had some pretty intense oral surgery recently, with more of it on the way. So anything involving me talking is going to be a little bit slow going for a while. But I have been spending my recovery time productively. I have been extensively researching gem and mineral mining, and it is fascinating stuff. I was expecting the working conditions to be harsh, but what I wasn't expecting was how large and aggressive the wildlife is down there. This is going to require a lot more research, so bear with me.